Here we're just going to be looking at what is an exponential function, and we're going to be looking at this equation. So an exponential function is an equation of y equals to your a to the x and plus q, where your q represent what? The horizontal. So it's horizontal, okay, maybe horizontal what asymptote. So in asymptotes, we don't touch the asymptote, but we approach it. So the graph approaches the asymptote, but doesn't touch it. And since we don't have q in this equation, it means that q is 0. So it's more like we have a to the x then plus 0. So we can see that there is actually an asymptote at x equals to 0. Actually it's y being 0. So at y equals to 0 we have what? An asymptote. Okay, all right, so now let's continue with the questions to understand this better. And I'm going to hint as well on a log function, and the log function is what is the inverse of an exponential function. Okay, so let's write down the coordinates for t for the first question. So t here, we can see that t is what is a y-intercept. And for a y-intercept, we let x be 0 or x equal to 0. So when we let x equal to 0, we get t of 0 equal to your a exponent 0. And this is 1, so t will be 0 is to 1. Okay, so now let's go to the second question. For the second question, we are required to calculate the value of a. And for the value of a, we need what? The point. So we have this g of x being equal to what? Your a exponent x. And if we substitute a point s, which is what? Which is 2, 9, or is to 9. So we have 9 equal to your a exponent 2 or a squared. So your a is equal to 3, because if you root both sides, you get 3. But why don't we take, because if you root, you get plus or minus 3. Why don't we take the option of -3? The reason is simple. It's just because of the shape of the function. So the shape of the function looks like this. So if the shape of the function looks like this, we have your a being positive or greater than 0. So let's assume that a was negative. This will mean that it will be a reflection about what? About the x-axis. So if it is a reflection about the x-axis, you're just going to have something looking like this. So it's when a is what? Is negative or less than 0. But what happens if our a, if instead of 3 we had 1/3? So we will be having something looking like this. Why will that be? It will be a reflection about what? About the y-axis. A reflection about the y-axis will be having 3 exponent negative x, because it's just changed the sign, and you can see that we have. Okay, maybe let's not get much deep into it at the beginning, and then I'm going to explain it as we go along with questions for an exponential function. So right now you have to know that we take a positive sign if we have a greater than 0. We have a graph looking like this if a is greater than 0. So if a is less than 0, we're going to have a graph looking like that, because it is a reflection about the x-axis. As you can see, we have the same x-axis, and then we see that the graph, the y values are different for this one. Let's continue with the questions. So we have a graph of h, which is obtained by reflecting g about what? About the y-axis. So if you reflect g about the y-axis, remember that we have g of x being equal to your 3 exponent x. So if you reflect it about the y-axis, when you reflect about y-axis, okay, y-axis, so reflection about the axis, y-axis or x-axis is pretty simple. So if you are reflecting about the y-axis, you let x equals to negative x. Okay, when you reflect about the x-axis, you let y equals to your negative you go to y equals to your negative y. So it's more like you don't let for y-axis, you if you reflect about y-axis, you don't let y equals to your negative x. It's more of something like a trick, but okay, you're gonna see y in the long run. Okay, so it may be important just to know that if you reflect about the y-axis, you let x equals to negative x, and then, or if you reflect about the y-axis, about the x-axis, you're going to let y equals to negative y. Okay, so what we're going to do here, we are reflecting about the y-axis, so we're going to let what x equals to negative x. So we're going to have g, more like g of negative x, be equal to what your 3 to the negative x, or else, okay, they said this is the graph of what of h, so this one will be equal to your h of x. So h of x will be 3 to the negative x, or which is the same as 1 over 3 exponent x, because you can see that this is just the same as what is 3 exponent negative 1 times x, and 3 exponent negative 1 is 1 over 3. So there we go. Okay, now we want to write down the x values for which the inverse of g is what lies between 0 and 1. Okay, so we want the inverse of g. So if we were to draw what the inverse of g, the inverse is simple interchanging x and y. So let me remove some of this. Okay, so we're going to remove some of it. All right, so let's remove this one as well. Okay, the inverse is what is there, is just an interchanging of what of x and y. So we know that g of x is equal to what, your 3 exponent x, and then your x will be equal to your 3 exponent y when you interchange x and y. So this one will be y equal to your log 3x. So you can see this is what they are talking about in the last question. They say log 3x lies between 0 and 1. But then we can try to cheat this. We know that when x, for the original function, when x is lying between 0 and 1 here, okay, let's look at the original function. When x is 0 here, what is y when x is 0? When x is 0, y is 1. When x is 1, what is our y? When you plug in 1 here, what do you get? You get 3. So y is 3 when x is 1. But then we are asked of what? Of an inverse, or the log. And we said that the log function, we interchange x and y. And interchanging x and y, this means that this becomes your y and this becomes what, your x. But then we already know that the y is what is log 3x lying between what, 0 and 1. So when you interchange x, you get what, the answer that we are looking for. So your x will lie between 0 and 3 for the final answer. So you just have to be a little bit more careful for the last one. Okay, what you just do is just look at x, that the x value is lying between 0 and 1 in the original function. okay, for you to have y here. Then you can look at what was the original y value when x was lying between 0, and 1. You can look at those y values, and those y values will become the x value when you interchange, and when you interchange you just get the log, which is what we have.